Okay, good morning. Here's what we're going to do today. If you did not finish yesterday's assignment on the respiratory system, its functions and the different parts that make up that system, you're going to want to complete that first. And then following your completion of that assignment, you're going to want to listen to this video in full. So if you're listening to me first without doing the assignment, pause the video, go back, complete your assignment from yesterday, and then listen to me as I review and go through that information with you. So the first thing you had to do was talk about the functions of the respiratory system. So what is respiratory system? Well, if we think of the word respiration, respiration means breathing. So if we talk about your respiration, we're talking about your breathing. So one of the main functions is to bring air with oxygen into your body when you inhale. An inhale means breathe in, and to take carbon dioxide out of your body when you exhale or breathe out. So it's moving air in and out of your body, taking in the essential gas that it needs and expelling the waste that it doesn't. And carbon dioxide is considered a waste product. The other thing, which is what we usually don't think of when we think of respiration, is as we're breathing in that oxygen is also being supplied to our bloodstream. And then another system, which we'll learn about next, called the circulatory system, delivers that oxygen to the blood cells. When we exhale, not only does carbon dioxide come out of our body, but it also comes out of the bloodstream as well, because it's a waste product and we don't need it, it's harmful. So when we talk about the different structures of the respiratory system, let's start by how air enters our body. And it can enter in two places. The oxygen can enter through our nose and it can enter through our mouth. When we inhale, what's going to happen is the air is going to go in, our diaphragm muscle is going to contract, and it's going to move downward. Now, your diaphragm muscle is under your rib cage, okay? And it's kind of a long, smooth, flat muscle. So when I take oxygen in from my nose or my mouth, it moves down or causes the diaphragm to push downward, okay? And the muscle contracts. When I exhale carbon dioxide out of my mouth or out of my nose, it's going to cause that diaphragm muscle to move up and relax, which kind of makes sense because it's like pushing the air out of our lungs. So when I breathe in, the muscle pushes downward because it's pushing air into our lungs. And when I breathe out, that muscle moves up to push the air out of our lungs. Now, there's some interesting things to know about our nose and our mouth. Our nose is lined with nose hairs, and I'm not going to show you my nose hairs because that's gross. But those tiny hairs are called cilia. And cilia actually is a filtration system. So it catches particles that we don't want in there and it traps particles. When you sneeze, it's because your cilia has those built up particles, so you're sneezing to try to clear it out of your nose. Your eyelashes, kind of interesting, form a similar function where it tries to keep particles out of your eye from going into your eye. Now, your mouth and your nose are both lined with mucus. When you blow out and you get some like thick crud in there, that's the mucus. We need mucus because the mucus moistens our air. So when we're taking it in, it doesn't go in dry and harm our lungs. So you do need mucus. You just don't need an excessive mucus. Now, the reason your mouth is a secondary filter, or secondary, I should say, source of air is because it doesn't filter the air as well. So we breathe out of our mouth as our We breathe out of our nose as our primary source of taking in oxygen. But if you have a cold and your nose is blocked, you broke your nose, you have surgery and you got stuff packed up there, you have a secondary way of getting air in through your mouth. However, it doesn't filter air as well. So your nose is your primary source for breathing. Now, once that air enters your nose and your mouth, it's going to go down a passageway known as your pharynx. Your pharynx is your throat, and your pharynx is going to reappear when we talk about your digestive system because it has two functions. But in the respiratory system, it's a passageway for air. And tomorrow you'll see a diagram and you'll see the location of where your pharynx is. From your pharynx, you are going to have your air go into your trachea. And your trachea is your windpipe. So it's a long tube that kind of connects your pharynx to your lungs. This trachea is also lined with cilia, those tiny hairs to filter out air, which is why you cough if you get dust particles in there. And it's also lined with mucus, again, to moisten the air so it doesn't harm when we go into our lungs. Now, your trachea is lined with rings of cartilage all the way down. And when you're having an asthma attack, those rings of cartilage actually close, which is why you have difficulty breathing. So when you take an inhaler, it relaxes those rings of cartilage, opening them up so you can get air through your trachea. This is also why people choke. When you are eating, there is a tube you want food to go down called the esophagus that leads to your stomach. Sometimes when they say it goes down the wrong pipe or the wrong hole, what happens is the food goes down your trachea, which is your windpipe, right? And that's your source of air. So if you get food stuck in your trachea, then you can't breathe because it's blocking your airway or your windpipe. This is why they perform the Heimlich maneuver. When the Heimlich maneuver is performed, they're actually pushing that muscle, that diaphragm, pushing on it, so air gets shoved into your lungs, up the trachea to pop out that food that's stuck there. So that's the purpose of the Heimlich maneuver, to get food out of your trachea. So your trachea is your windpipe. You don't want food down there, but every now and then, and you'll see why when we get to the digestive system, sometimes it gets stuck there. But we pop it out by forcing air into our lungs, up the trachea to pop it out, and it comes out through our pharynx and out through our mouth. From the trachea then divides into two tubes called the bronchi tubes, or the bronchus. And each tube leads to a lung. So a left bronchi tube leads to the left lung, and the right bronchi tube leads to the right lung. Those bronchi tubes are going to further branch off into smaller tubes. So it almost kind of looks like a tree with a bunch of tree branches inside your lungs. And those smaller tubes are called the bronchioles. The bronchioles attached to them are the alveoli, and the alveoli are super important. They're air sacs at the end of the bronchioles. So they're air sacs in your lungs. And I'm just looking at my fact here. There's 600 million alveoli in your lungs. Now, if you could take those alveoli and spread them out, they would cover an entire tennis court, which is kind of pretty cool. So when you inhale, not only does the oxygen go into your body, but it fills those alveoli. It fills them with oxygen, and your lungs actually expand. The alveoli takes that oxygen and puts it into your bloodstream. And then the circulatory system will carry that throughout your body, so your cells will have the oxygen that it needs. When you are exhaling and the carbon dioxide comes out of your body, first it comes out of the alveoli. It's the alveoli taking it out of your bloodstream. So the alveoli is the place where gas exchange is happening between the blood and the air. So the alveoli takes oxygen from the air you're inhaling, puts it into the bloodstream, and the circulatory system carries that out. The alveoli takes carbon dioxide out of the bloodstream, and when you exhale, it comes out of your body so you don't get carbon dioxide in your blood. So alveoli is super important because it's the place of the gas exchange. When we talk about our lungs, which is where we find these structures, the bronchi tubes, the bronchioles, the alveoli, our lungs serve two purposes. One, respiration, breathing, okay? Taking oxygen in, exhaling carbon dioxide out. But the other one is this is the place where that gas exchange happens between the air and the blood, and the alveoli is responsible for that. Alveoli puts oxygen into our blood as we inhale it into our body through our nose and our mouth. And the alveoli takes carbon dioxide out of our blood, and when we exhale, it gets rid of it. So a lot of cool structures there. So I'm just going to go quickly again what happens when we breathe, when we inhale, and then the reverse when we exhale. So when we inhale or breathe in, we're taking in air, mainly through our nose, but we have our secondary source, our mouth. So we're taking in the air. It's going down the pharynx, which is our throat, to our trachea, which is our windpipe. That trachea is going to branch off into two tubes called the bronchi tubes, one going to the left lung, one going to the right lung. Those bronchi tubes are then going to branch off into smaller tube systems called bronchioles. Again, left lung, right lung have these bronchioles. At the end of the bronchioles, we have the alveoli, which are the air sacs, over 600 million of them, taking the oxygen, putting it into our blood, and taking the carbon dioxide out of our blood. As we inhale, our lungs are getting bigger as they fill with oxygen. Now, when we exhale, the reverse is happening. Okay, the alveoli is taking the carbon dioxide out of our blood. They are going from the alveoli to the bronchioles, up to the bronchi tubes, up through the trachea, which is our windpipe, up to our pharynx, which is our throat, and out mainly through our nose, but can also exhale through our mouth, and then the carbon dioxide comes out. So it's kind of the process in reverse. From here, tomorrow, what we are going to do is I will have a couple of videos for you that will show you this process. One is a little graphic. It's a dissection of a lung. So it will actually show you these different features. If you are not interested in watching that one, you don't have to. If you're a little squeamish, if you don't like stuff like that, you can skip over that one. There'll be a little disclaimer that says watch with caution. And there'll also be a diagram with the parts labeled. And there'll be another video of me kind of talking about the parts, just reminding you again. But don't forget, PowerPoint, questions, me summarizing this information. As always, you can reach me through Google Classroom. You can call me directly on my cell phone if you need to ask me questions. Watch this video as many times as you need to help you out. Have a great day. If it's a nice day outside, please make sure you get outside and take some time for yourself. Go for a walk, a bike ride with family. Okay, you always want to build in time for you too. Have a great day. Keep breathing, respiration, and remember, this is one of those involuntary things that we do automatically without thinking. We're not sitting here thinking, breathe in, breathe out, breathe in, breathe out, okay? Again, this is working with our nervous system, our autonomic nervous system, involuntary, no control over it. It's happening without us thinking about it. Have a great day, and I'll talk to you soon.